differentiating from first principles then. So we know what the answer is before we start. We know that the answer is going to be 10x plus 8, but we have to arrive at that answer. Now then, to differentiate from first principles, we'll take 2 points on a curve, take a general point P, which is at the x coordinate, so that's x comma, and the corresponding y coordinate will be 5x squared plus 8x minus 11. Then move along the curve a small distance so that the x coordinate has increased by a small amount h. And then the corresponding y coordinate will be the expression here for y, but when I see an x I replace it with x plus h. So it's 5 lots of x plus h squared plus 8 lots of x plus h minus 11. So there's the two coordinates. So the gradient of the chord PQ, okay, so the gradient of the chord PQ is y2 minus y1 over x2 minus x1, so it'll be 5x plus h squared plus 8x plus h minus 11. Take away y1, which are those three terms there, so I need a bracket for those three terms. That's 5x squared plus 8x minus 11, and that will be all over x2 minus x1, which is x plus h take away x. Okay, let's expand the top line then. So that's 5 lots of, now squaring this bracket, square the first, multiply them together and double it, 2xh, square the last is h squared, plus expand this bracket, 8x plus 8h minus 11. Then this minus sign will change all the signs of this term inside. Minus 5x squared minus 8x plus 11. All over x, take away x cancels, leaving me with h. Just expand this bracket down with 5, that's 5x squared plus 10xh plus 5h squared plus 8x plus 8h minus 11 minus 5x squared minus 8x plus 11 divided by h. Remember, I'm still working the gradient of the chord PQ here. So 5x squared take away 5x squared cancels. 8x take away 8x cancels, and I got minus 11 plus 11. So the top line becomes 10xh plus 5h squared plus 8h divided by h. H is a common factor on the top line, so taking the h out, that's 10x plus 5h plus 8 divided by h, and h is cancelled. So the gradient of the chord PQ is 10x plus 5h plus 8, and then in the limb, as h tends to naught, Q approaches P, and then that chord becomes a tangent at P. So then I got the gradient of tangent at P is, and if h is 0, 5h is naught, 10x plus 8. And the gradient of the tangent is given by dy by dx equals 10x plus 8. So we knew the answer before we started, but we need to go through that process. Part B, differentiate this expression. Let's write it as y is 6x to the 2/3. Right, 5 over x squared, I need to bring the x squared power up on top. It's 5x to the power of minus 2 minus 4, and now I can find dy by dx. So The 2/3 comes down, so that's 6 lots of 2/3. X to the power of, right, 2/3 take away 1. So 2/3, 1 is 3/3, so 2/3 take away 3/3, that's minus 1/3. For this term, the minus 2 comes down, so that's minus 2 times 5, minus 10. X to the power of, and if I take 1 away from minus 2 minus 1 is minus 3. And differentiate 4 is 0. So that's 2/3 of 6. So 3 into 6 was twice, 2 2s are 4. 4x to the minus 1/3 minus 10x to the minus 3. Negative power comes underneath. So that's 4 over x to the 1/3 minus 10 over x cubed.